Okay, welcome to lesson 130 of algebraic concepts, or lesson 2130 overall. So today we're going to be factoring trinomials where the leading term a, I should put that, oh that is black. Oh wait, I'm going to highlight, I wonder. Okay, where a is not 1. So let us go over some things here. Okay, there's our objective, there's some vocabulary, some rules and notes. I put this picture in. I don't want you to get dogmatic. Well, I don't want you to be strictly routined in thinking that this rule applies. I put this on here because it works for some trinomials, but it does not work for all trinomials. So please read through this carefully. Here's another way of doing it where you have to go through, like I said in a previous video, and check your work. So if this is your first video on this channel, I've done, I don't know, 10 or 15 previous lessons dealing with binomials, trinomials. So please go ahead and watch a couple of them before you finish this video. Because I said in other things, when you come up with a solution, you're going to have to go back and check your math by foiling out or distributing whatever you factored out. Okay, so let's look at our first trinomial where the leading term has a coefficient that's not 1. Okay, so what the picture, or the two slides with the pictures on them, or the visual, was trying to show you, the first thing you got to do is factor your constant term. Your constant term is the one without the variable. 3 is a prime number, so its only factors are 1 and 3. So now how this works out is you're going to have 2x plus 1 and an x plus 3. That is one possible solution. Or it could be 2x plus 3 and then x plus 1. Now, off the top of my head, and there may be a couple of math teachers that will tell you, they could look at it and tell you which factor is going to work. I'm not going to do that. I'm going to tell you to check and make sure it's going to be one of these two scenarios. And how do I know that it's plus? Because both terms are plus. So what you're going to have to do in this situation is go ahead and FOIL them. So we're going to do our first, our outers, our inners, and our last. And so let's see. You get 2x. Let me put this in blue. I made this mistake in the last video. Let's put this in blue. No, red is our first term. We get 2x squared plus our next term, which is 6x, which is our green term, which is our inners, 1x, plus our last term, which is 3. And 6x plus 1x makes 7x, so this is the one that works. So we got lucky and found it correctly on the first term. Sometimes you're going to have to get your factors and do both. Now, let me show you how the other term works out. So if I do my first, I get 2x squared. If I do my last, I get plus 2x. If I do my inners, I get 3x. And if I do my last, I get 3. I get 2x squared plus 5x plus 3. And as you can see, this is not the original term. So this does not work. Sometimes you're going to get factors. Go ahead and FOIL them out. It won't be wrong. All you got to do is switch the last two terms, or the second term in each binomial. That works when you have a prime number. That's what it looks like. All right, so 8. We have negative 8, so we have to be careful here. So what are our factors of 8? 1 and 8, 2 and 4. So we can have negative 1 and positive 8. We can have positive 1 and negative 8. We have negative 2 and positive 4. We can have positive 2 and negative 4. Any of these can work for our binomials. So let's just try all solutions. And I'm not going to give you any formulas or any shortcuts. I'm going to say try. And we're lucky that we're dealing with odds. We don't have any factors on our leading coefficient, which would get into a whole nother thing. So let's try 5y minus 1 and then y plus 8. And we have to try all of them to see what works. So if we foil this, we get 5y squared, outers, plus 40, minus 1, minus 8. That will give us 39. This does not work. Okay, so let's try a different one. So let's try 5y plus 1 and then y minus 8. And this gives us 5y squared, outers minus 40y, inners plus 1y minus 8. Okay, this doesn't work. All right, so let's try another one. Let's try 5y minus 2 and then y plus 4. All right, 5y squared, outers plus 20y, inners minus 2y minus 8. 20 minus 2 is positive 18. We have a negative 18. Okay, so as you can see, we had to try several factors. So as we can see, what is going to work? 5y plus 2 and then y minus 4. And this will give us, if we FOIL it, 5y squared minus 20y plus 2y minus 8. Sometimes your factors might have to work backwards, so you're going to have to try all kinds of things. Minus 18y minus 8. So this is the one that works. And I know it looks like we did a lot of math, and I know I went through and did the foiling kind of quickly, but I set up foiling in a previous video dealing with binomials. So please watch that video again if you feel like I went too fast through the foiling or how I multiplied these binomials together. I use a method called FOIL, which is first, outers, inners, last. And there you go. You have to check your work when it comes to doing math, especially as you get to higher levels. And as you practice more math, you can see multiplication in your head. You can just see it work on paper. But when it comes to factoring things, you're going to have to try all the factors. You might have to switch them around. Maybe I could have switched the 8 and the 1s or the 2s and the 4s if none of these 4 worked out. Sometimes it just takes a lot of trial and effort. And if you keep trying it and doing it different ways, you will eventually catch on. There are no shortcuts. You have to work the process. Okay, so this trinomial is out of order. So the first thing we got to do is put the trinomial in order. 3m squared minus 21m plus 54. Now, I hate dealing with negatives personally. So what I'm going to do is factor out a -1. And that changes all the signs inside the trinomial. And so now, I know I'm going to be dealing with 3m plus something and then just regular m. Okay. Minus something. Because this is a -54. So now we need all the factors of 54. Oh, this is going to be brutal. The factors of 54. 1 and 54. 2 and 27. 3 and 18. 4 doesn't go in. 5 doesn't go in. 6 and 9. 7, 8, 9, 9 and 6, 10, 11, 12. 12 is 48 and 60. 13, 26, 39, 52. 14, 28, 56. Nope. 15, nope. 16, 32, 48, 64. Nope. 17, 34, 51. Nope. All right, so these are our factors of 54. So we're going to have to go through and do all of these to see which ones give us 21 in the middle. So let's try. All right, so let's try 1 and 54 to see what happens. And I will be erasing on this slide. So I get 3m squared. 54 times 3. 3 5s is 15. So that's minus 162 plus 1m minus 54. Not even close. So this doesn't work. And if I go the other way, I'll get plus 162 minus 1m. So 1 and 54 do not work. So I'm going to erase this out. I'm going to show you all of my trial and errors so that you see what you have to do. And some of you may be frustrated thinking that it should be easier, but sometimes it is not. So please don't think that we can just skate through. All right, let's try 2 and 27. Let me put it back on my pen. So let's try 2 and 27. If I could write it 2, 27. Okay, so I get first 3m squared, and then 3 times 27. 3 times 2 is 6. 60 plus 21 is 81. Minus 81m plus 2m. And I know the last thing is going to be minus 54. All right, let's see. Does that work? No, that gives us negative something crazy. And we're looking for 21. And remember, we're looking for positive 21, not negative 21. So that doesn't get us close. If I switch to 27 and 2 around, I get 27m. Oh, what if I do this? Okay, I see it now. I see it now. Look at this, people. What if I put the 27 here and the 2 here? What is going to happen? So the first are 3m squared, stay the same. Minus 54 is the last term. So I get minus 6m plus 27m. So 3m squared plus 21m minus 54. All multiplied by negative 1. Distribute that. I get negative 3m squared minus 21m plus 54. Is that my original term? Yes, it is. And you saw all the trial and errors that I went through to get there, but it works. So keep working the process. This is the correct answer. That's your correct answer. What we had to do down here was check and verify that this answer was correct, was the correct factors of this trinomial. Okay, so those were our 3 examples. As always, work on the practice problems, and I will see you at the end of the video for a short recap. Okay, so what's our first term? 21 squared. 49 is a square. So what are we going to have? What are the factors of 21? All right, so the first thing we need are the factors of 49, which is 7. That's it. 1 and 49, and then 7 and 7, and that's it. 49 is a prime number. Okay. Well, it's not a prime. It has 7 as a factor. All right, so 21 has factors, has 3 and 7 as factors. And so let's try 3y plus 7, and then, wait, all right, so our middle term is negative, so that should be negative in the middle. See, even I have to think about all of these things. And then 7y minus 7. Okay, we may have to mess around with these to get them to work. Okay, so first you get 21y squared. Then the outers, minus 21y minus 49y plus 49. First, outers, inners, last. Okay, that works. 21 and 49 make 70. Oh, look at this, people. We got lucky on the first try. Sometimes you get lucky on the first try. But what did I do? I found a binomial that I thought, well, that had the factors of the first term and the last term. Then I went on and tried it. I verified it. I went through and go ahead and factored it out so that you would see that it works. Okay, so there you go. Let's go into the next problem. Factorable, which is weird. All right. This is easy because 5 is prime, 2 is prime. So let's try 5m plus 2, and then m. Oh, our middle term is negative. So that's the first thing you have to do is look at the signs in front of your terms. You're going to have 2 negative binomials, m minus 1. Let's see what we get here. So we get 5m squared minus 5m minus 2m plus 2. Negative 5 is negative 7m. This one doesn't work. So let's do 5m minus 1, and then m minus 2. Let's see what this works. You get 5m squared. The outers is minus 10m. The inners is minus 1m and plus 2. I get 5m squared minus 11m plus 2. That does not give me 13. We tried the 2 and a 1 in both spots. Does not make a difference. You don't need to switch the first term. So I would say as of right now, this trinomial is this is not factorable. There are some trinomials that are not factorable. So don't be alarmed. Sometimes things don't work out. So I've been every example that we had worked out previously, but sometimes there are things where the things don't work out. And that's what we come to. We hit a fork in the road. Maybe this number should have been 11, but it's fine that it's 13 because that shows us that there is no solution. And there were several videos way back in the past that had no solutions. I think it was in the previous series dealing with linear systems where there were no solutions. You did not see an example of no solutions, but here you do. So I'm glad this problem came up. This is not factorable. So do not worry if you did not get an answer that worked. It wasn't your fault. Some trinomials are just not factorable. Okay, 2x, I think we did this in the beginning, but it was 7x. All right, so the factors of 3 are 3 and 1. So let's say 2x plus 1, x plus 3. Falling it out, we get 2x squared, outers plus 6x plus 1x plus 3. Nope, doesn't work. So we got 2x plus 3 and then x plus 1. You get 2x squared plus 3x. I did the inners, I didn't do the outers. Plus 2x plus 3. All right, so that's first, inners, outers last. 2x squared plus 5x plus 3. And look at that. There you go. Okay. Look at this. All of these terms have a 4 in factor. So we can factor a 4 out. And let's see what our trinomial looks like if we factor a 4 out. The factors of 3. This is going to be a little bit weird. Look at this. You got a positive in the middle and a negative at the end, which tells you that one term is bigger by 2 than your other term. So let's try 2x plus 3 and then x minus 1. Let's see what we get with a 4 on the outside. So 4 times 2x squared, outers minus 2x, inners plus 3x minus 3. This gives us 2x squared plus 1x minus 3. That one didn't work. So let us try 4 times the quantity 2x plus 1 x minus 3. That's going to give us negative in the middle. All right, 2x squared minus 6x plus 1x minus 3 times 4. That gives us negative 5x in the middle. Why am I creating all this trouble and drama? Right now, this one looks not factorable. Okay, so you may be wondering why we are factoring trinomials. This will come up in Algebra 2, and I will get to that eventually. I have to go through some other things. I will be getting Algebra 2, but the reason why we factor trinomials is to help us with the graphing of trinomials, and we're looking for where it crosses the x-axis. But that comes up in graphing. I will be getting to that later on down the line. And when something is not factorable, it just means that the graph of the trinomial does not cross the x-axis. So it is fine for trinomials not to be factorable. It is fine that you do not come up with an answer. Just make sure, like I said, you do the math, you check your work, and you go through all the steps necessary to solve a problem. And thank you for watching this video. We came up with 2 that were not factorable right in a row, which is weird because usually I try to make everything work out. But sometimes in math, things have no solution, and we have to accept that as a possible answer. But I would not accept that as your first answer. I would do the work. I would check my work. I would work back through and make sure all of my steps worked out. And once you do that, and if you still come up with a solution, then you just have to accept that it is what it is. Now, when we get to Algebra 2, there will be a shorter way of finding the factors of a trinomial. There's a different way. There's a formula that we're going to use, but you have to see the graph of this trinomial first before we can get to that. So that will be coming up in Algebra 2, which is way down the line. So thank you for watching this video. I hope to see you on the next video. And if I did anything too quickly, please go back and watch some of the earlier videos in this series, which I believe started around 2114 to 2115, something like that. So there you go. I hope to see you on the next video.